Welcome to section 8.5. In this section, we're going to be working with very special cases of products. So we're going to learn how to factor various things called perfect square trinomials, and we're going to be doing factoring of difference of squares. And this is stuff we have already done. We've just never done it in this way. You've always used FOIL, and now we're actually going to go backwards, and we're going to, instead of do FOIL, we're going to find its original factor pair and factor set. So this is section 8.5. It's called factoring special products. So you should have a missing page already set up called factoring special products, and what you need for this is your missing page. So you need that totally set up. Make sure it's headed properly, put in with the proper page numbers, all that jazz. Make sure it's in your table of contents and your set. You also need a notes page that the sub should give you. Make sure that's there. It's just a half sheet of paper that says on the top, section 8.5, factoring special products, and it says perfect square trinomials as a major heading and factoring difference of squares. Please make sure that's taped into your missing. This piece of paper will be sort of the basis of all your notes pages, and if you ever see this thing right here, N with a couple of little like nice little spikies coming off of it, you know specifically that needs to go on your notes page. Okay? That notes page is really important, so that way you can always refer back to it in your missing, and I don't necessarily have to be called all the time. Regardless, I love hearing your beautiful voices, even if it's at 9 o'clock at night when you are working on your homework, so feel free to still do that. So let's get started. Let's start first with these two cases. You have these on your notes page, so here you go, notes. I would like you to do the following. I would like you to solve this. So essentially we're doing FOIL on this thing. You are essentially taking it from 2x plus 3 squared, and you are actually doing that math. And in order to do that math, we have to pay attention to what squared means, and that means everything inside the parentheses is going to be repeated as many times as the exponent tells us to repeat it. So here is an example of how this 2x plus 3 should be written out. 2x plus 3 squared, I should say. Now you need to write out 4x minus 2 properly. So please, what I'd like you to do is FOIL these two products and find what they look like as trinomials. So as that sort of maybe 2x squared or 4x squared or whatever it may be, figure out what it looks like as a trinomial with 3 different terms. Pause this video and do that, and I will, the next time you start it, you will see the answers as well so you can follow along. But please do that in your missing right now, so pause. Okay, so now that we're unpaused, let's check this out. I essentially have done this work for us, and so let's look at 2x plus 3, that quantity squared, that will end up factoring out to be, or that will end up multiplying out to be 4x squared plus 6x plus 6x is 12x. And then we have plus 9. And then we can also look at our other side. We have 16x squared. Negative 8 plus negative 8x equals negative 16x. Negative 16x plus 4. So now what I would like you to do is I want you to pay very close attention to our first term and our last term of both of these. And I want you to see how they relate back up to our original problem. Looking at that information, how do these numbers relate? And hopefully you're going to find that they relate quite nicely to each other. So pause the video, talk with your iPad partners, and determine how they relate to each other. Okay, so I've moved everything up a little bit, but I'm looking at what do I notice and that sort of thing of the 4x squared and the 9 compared to the 2x and the 3. Well, if I think about it, 2x, that quantity squared, if I think about it, is 4x squared. 3 squared is 9. So there is a direct correlation. It all makes sense. As well, I can also say the same thing. The 4x is essentially 4x times 4x is a 16x squared, and I can also say the same thing about negative 2 squared is a positive 4. So there is a direct correlation. That's all I'm getting at right now. So it relates to the original format and saying the original format is just the square root of what we were looking at, or like our answer is essentially the squared terms of our original. So let's go up and we're going to look at something very special and very general. So this is also, if you look at this, it's on your notes page. So a squared plus 2ab plus b squared, that is the format that we came up with after we did our FOIL technique. And this is how we can factor it. A squared plus 2ab plus b squared can factor out to be a plus b times a plus b, which is equal to a plus b squared. It's in your notes. Please add it. So now also we can also look at a squared minus 2ab plus b squared. We can look at that, and we can also see there is a direct correlation between a minus b times a minus b, which is a minus b squared. And if we were to go back and look at our original work, our original problem, we have our original problems. Here is that this 2x plus 3 squared is essentially a plus b squared, and this 4x minus 2 squared is essentially a minus b squared. Same format, ends up being the same thing as this situation. So we can, if we're given the right tools, if we can see this, we can factor it into what it should look like as a factored form. That is our whole goal. We are given this information and we need to get here. That's our end result. All right, we're given this, we need to get here, end result. So now let's actually see if we can recognize that. So this, again, is in your notes page. What will this look like? We have 9x squared minus 6x plus 4. We can essentially say, oh, this looks like a squared minus 2ab plus b squared. I know that's a stretch. Let's go with me here, okay? Go on this journey. Here we go. If I look at 9x squared minus 6x plus 4, I can try to find what a is and what b is. And in order to do that, I need to think of these numbers as not 9, but what is 9 as a number that could be squared? It is 3 squared. I can also look at 4 and think the same thing. That is 2 squared. So step 1 of this situation, step number 1, you essentially need to rewrite this original equation as sort of a square of itself. And if I were to do that, let's look at our first term. The 9 can be written as 3 times 3. The x squared can be written as x times x. I'm actually going to avoid our middle term altogether, and I'm just going to look at the 4, and we can write that as 2 times 2. Now our whole ultimate goal is that whatever we end up getting for our middle term, hopefully it is a good composite. Hopefully it's this negative 2 times a times b situation. And we can always fix or see if that works with FOIL. So step 2 of our process is actually writing this out as two binomials. So our first, we're going to take one of each of our terms. We have a 3 and an x as our a. We have a 2 as our b. And we have a minus sign here, so I'm going to put a subtraction sign. I'm going to do the same thing with this other side. We have a 3 and an x, and I'm going to put a 2. Wow. and a subtraction sign. So in all reality, we can rewrite this whole thing as saying 3x minus 2, that quantity squared. Now let's actually check and make sure our work actually makes sense. Oops, I shouldn't have actually drawn that big, ugly thing. Let's actually check and make sure our work actually makes sense. So if we were to do FOIL on 3x minus 2 times 3x minus 2, essentially that 3x minus 2 squared situation, we can move that and turn it into this stuff. If we're actually going to do FOIL on it, here's my first term. 3x times 3x is 9x squared. Here's our outside term. We have 3x times a negative 2, that's equal negative 6x. Inside term, we have negative 2 times 3x, negative 6x. This is looking good. And our last term, we have a positive 4. And in all reality, when I do the math, I have 9x squared minus 12x plus 4. Ooh, I see a problem. I initially thought this negative 6x, I thought that would look good. But when I actually do the math, I have negative 12x. One thing we need to make sure of is if we have a perfect square trinomial, this middle term needs to make sense with everything. What we have here, the negative 6x plus 4, that's not a perfect square trinomial. A perfect square trinomial for this certain situation, for 3x minus 2 squared, would look like this. So you'll see this in your work, or in your homework today. You need to check your work to say if something is or is not. Sorry, I initially wrote yes. Is or is not a perfect square trinomial, and this one is not a perfect square trinomial because that middle term is wrong. Let's try one that is a perfect square trinomial. Just trying to screw with your heads. Let's try one that is a perfect square trinomial. Here we go. We have 16x to the fourth plus 40x squared plus 25. Now, don't get thrown off by the fact that, ooh, this one has a plus sign here and the other one had a minus sign. You're going to have situations where you have a minus sign with this middle term, and this is truly a perfect square trinomial. This particular situation, I know it's going to work, but it's going to definitely also follow this situation, a squared plus 2ab plus b squared. Okay, it's going to definitely follow this situation. So let's do our step 1. Step 1 tells us that we need to essentially find the square root of 16, which is 4 times 4. And we need to also maybe write out all of these x's. We could also find the square root of x to the fourth, which is x squared. But let's write out all those x's, and it'll make more sense. Let's also write out the square root of 25, which is 5 times 5. So that's our step 1. Our step 2 then tells us that we need to write this in essentially the form that will work for a squared plus 2ab plus b squared if we were to write it in factored form, which is essentially a plus b times a plus b. Doing that, we can essentially say, okay, here's 4. That's going to be part of my a, and I'm also going to take 2 of these x's, so I'm going to write x squared. I'm going to take one of these b terms over here, and I'm going to put that in parentheses. And I'm going to put a plus sign here because there is a plus sign in my original equation. There's no minus sign. Then I'm going to also take my other 4 that was remaining and my other 2 x's, x squared, and my last plus 5, and have that last little bit there. Let's actually check our work, see if it actually works out, see if it is a perfect square trinomial, and really what we're paying attention to is we need to pay attention to our inside and outside terms, but let's make sure it all works. So 4x squared times 4x squared equals 16x to the fourth. Our outside term, we have 4x squared times 5 is 20x squared. Inside term, 5 times 4x squared is 20x squared. And our last terms, 5 times 5 is 25. So we'll end up, when we combine like terms, we'll have 16x to the fourth plus 40x squared plus 25. yes, this is a perfect square trinomial, and it fits our original equation. It works. So here is our final answer. You could also rewrite this as saying 4x squared plus 5 quantity squared. So either one is good. I would be okay with either of those. So we know how to now identify if something is a perfect square trinomial. It either needs to fit one of these two roadmaps. It either needs to fit this one, a squared plus 2ab plus b squared initially, or this one, a squared minus 2ab plus b squared. Needs to fit one of those two situations, and when you factor it out, it needs to look like a plus b squared or a minus b squared. And I insist to, please check your work, because you can see in the last example, not this one, but that one up there, that if you don't check your work, you could end up saying, yes, this is a perfect square trinomial, this totally works, and it totally doesn't. So don't be bombastic spectacular and crash and burn like that. That would be no fun. So let's go on and do our last little thing. And I want you to remember this. Do you remember this situation where we have x plus 4, x minus 4, and if we were to actually do FOIL on it, x times x is x squared, x times a negative 4 is negative 4x, inside terms 4x, and that's a positive one, and then 4 times 4 is 16. Looking at these, they cancel out, they disappear, so we have x squared plus 16. Or, yeah, sorry, that's not a plus 16, it should be a minus 16. Because 4 times a negative 4 equals negative 16. So there we go. We have x squared minus 16. So essentially, if we have C ever this situation, we need to identify our A term, our B term, and then after that, we can put it into this situation where we have A plus B, A minus B. So hopefully you can do that on your note sheet. If you need to, pause the video so you can put that in there. Now, factoring difference of squares. This is also on your note sheet. So please fill out your note sheet so that you have this roadmap right here figured out. We have A minus B, A squared minus B squared is equal to A plus B, A minus B. That's a very specific example. So I would like you to do the same sort of thing that you did in the past with the other two problems. Find your A term, find your B term of this problem right here. We have 9p to the 4th minus q squared. And let's actually put it into our final form of this if we're going to factor it. So pause the video, see if you can identify the A term, see if you can identify the B term, and if you can take it all the way to finding the final factored form, awesome. If you can't, restart the video and you can see my work and see how it's done. So pause the video, find your A term, find your B term, go. So hopefully you paused the video and you actually did that. Let's actually find the A term and the B term here. So looking at this, this is my A term right there. So A term, we need to actually break it down into its squared form, or its basic form. So 9 is technically 3 times 3, and p to the 4th, we can write p times p times p times p. Lots of p's. Awesome. Hopefully you don't have to go to the bathroom. So now we have q squared, and we can write that as q times q. So looking at this, we can put this now into two binomials, and we can add and subtract them. And I'm only setting things up just so that way I can see where everything needs to go and I can kind of get everything started. I need to first take one of these 3's because I have 2 of them. And I see that I have 4p, so I'm going to split them up into 2. So I have p squared. And I'm going to take one of these q's and put it on this side. As well, I'm going to now take a 3 from this side and 2 of those p's, the last 2 remaining, and the last q remaining over here, and put q there. So here, technically, I think, let's check, is my final answer. But as always, check your work. So let's actually do that. Let's do FOIL on this thing. Remember that you can always FOIL things to check your work. So 3p squared times 3p squared, that's our first term. That'll end up being 9, because 3 times 3 is 9. And p squared times p squared, if we do our exponent rules right, those terms will add, and so we have p to the 4th. The outside term, 3p squared times a negative q will get us negative 3p squared q. Inside term, let's do that one. Q times 3p squared, they'll say 3p squared times q. I'm just rearranging it so it sounds better, it looks better, biggest to smallest sort of thing. And q times a negative q equals negative q squared. So if I were to actually put these all together, I could see that negative 3p squared q times, or plus 3p squared q, so those are going to cancel out, and I'll end up with 9p to the 4th minus q squared. That is exactly like my original answer. So this 3p squared plus q times 3p squared minus q is final answer, perfect form. And I hope between this tutorial video and potentially the other 2 videos you could watch as well, I hope you understand section 8.5. Thank you and see you tomorrow.